Okay, now we're going to get into some definite integrals in which it may not be as easy to figure out how to find the definite integral, and therefore we need to use substitution. Now these, again, some of you may be able to solve these without use substitution, which is fine. You can absolutely do that if you're capable of identifying the antiderivative of that term, and it's something which you should eventually be able to do, but in the meantime we have the use substitution tool to help us out. What I want to make sure that we are clear about with these types of problems is, besides identifying u like we did before and finding du like we did before with just basic antiderivatives and subbing in like we did before, we do have bounds now, and these bounds, keep in mind, are in terms of x, just like everything else. The differential is x. We are taking the antiderivative with respect to x. All right, we have 2x e to the x squared, and that's from x equals 2 to x equals 3. It's not actually written in there, but we technically could have it there. We could have x equals 2 to x equals 3. And if we do, in fact, consider that, well, if we change over to u in our differential and our integrand, when we don't want our bounds to be in terms of x anymore, we want our bounds to be in terms of u as well. So we have to change our bounds. We'll get into that in a second. Let's go ahead and do this. Identify u. Well, at this point, you're getting used to this. We see e to an inside function. That's going to become our u term. So u is going to become x squared. So let's put that down. And if u is equal to x squared, what does that make du? Very good. du is 2x dx. And lo and behold, we have the 2x dx. So we are all set to do our substitution. We don't have to put any numbers in, any numbers out front. Let's go ahead and do that. So we have here the antiderivative. Not going to write the bounds yet, okay? But I am going to write e to the u, and then 2x and dx are out, and du is in. So we have e to the u du, which means this is ready to go for an antiderivative. What we need for our bounds is to plug 2 and 3 into our connection, because we want our bounds to be in terms of u. Well, to connect from u to x, we have u is equal to x squared. So if x is 2, then u is 2 squared, or 4. And that 4 will become our new lower bound. Again, take the 2, plug it in for x, get the corresponding u term, and that's your new low bound. Since that was so much fun, let's repeat it for 3, our upper bound. If we plug in 3, so u would be 3 squared, or 9. So we are now looking at the integral from 4 to 9 of e to the u du. That will give us the exact same answer as the integral from 2 to 3 of 2x e to the x squared dx. But this is a nice basic antiderivative to work with, whereas this one's a little bit more complicated. However, they will give us the same answer. So what are we looking to do? Take something a little more complicated and turn it to something easy. It requires us to change our bounds, but no big deal. Let's try it again with this second one. We have the integral from 2 to 3 of x squared times the quantity x cubed minus 6 to the 4th. What's u? Very good. It's x cubed minus 6. And if that's the case, then du will be 3x squared dx. We have the x squared and the dx. We don't have the 3. No big deal. 3 on the inside, 1/3 on the outside, and we can proceed. We are now ready to substitute. So what do we have here? We have 1/3, our integral symbol. Hold off on the bounds for a second. Instead of x cubed minus 6 to the 4th, we will have u to the 4th. And the 3x squared and the dx are out, and du is in. Okay, what are the bounds? Well, let's take our 2 and our 3, because those are in terms of x, and let's change them to be in terms of u. So we're going to have 2 cubed minus 6 for our new low bound. 2 cubed, 2 times 2 times 2 is 8. 8 minus 6 is 2. So in fact, our low bound doesn't look like it changed, but it actually did, because it was x equals 2, now it's u equals 2. But ultimately, there's still 2 there. Then we plug in our 3. So we have 3 cubed minus 6. 3 times 3 times 3 is 27. Minus 6 means our new upper bound is 21, which is a pretty high upper bound. But we now have u to the 4th as opposed to x cubed minus 6 to the 4th. So we have something which is a nice, quick antiderivative. And with the next few videos, I'll actually do the antiderivatives with you so we can go from soup to nuts to find these definite integrals.